So this is Dr. Kavita Singh, Associate Professor from Department of Civil Engineering, Institute of Aeronautical Engineering. So today our topic will be about remote sensing satellites. So in the previous lecture we have just discussed about different kinds of satellite, different kinds of orbits, SWAP. So if you remember, we have just discussed there are two types of orbits like polar orbits and geostationary orbits. So in polar orbits the satellite will rotate in a direction north to south or south to north, and it is very near to the earth's surface. Whereas when you talk about the geostationary satellites, this is the satellites which are very far away from the earth's surface, and all the satellites like navigational satellites which gives us the continuous information, that all satellites comes under geostationary, and it is located 36,000 kilometers away from the earth's surface. So today in this lecture we are just going to discuss about different kinds of satellite, what are the different countries are having kinds of satellite, what is their resolutions and how they work and how they are useful. That all we are going to discuss in this lecture today. So let us start with the contents. So today our content is about Indian remote sensing satellites. First of all, we'll discuss about our Indian remote sensing satellites. Then the latest trends in the satellites. Then we have what are the satellites in the latest trends we have good. Cartosat 1, Cartosat 2, Resourcesat 1 and Iconos. So these are the few satellites we are going to discuss, which are nowadays very much important for the development of the any activity or development of the city. We require this kind of satellite images because it has a very good resolution along with a multispectral imaging system. So it has a pan as well as multispectral imaging system. So let us discuss about first of all Indian remote sensing satellite. So what is Indian remote sensing satellite? So our Indian remote sensing satellite, we call it as generally as IRS. So IRS is Indian remote sensing satellite. It has a series of series of satellites, like we have IRS 1A, 1B, 1C, IRS 1D. So these were the initial satellites in the series of launched between 1988 and 1997. So they provided multispectral imagery with moderate spatial resolution. Now, what is multispectral imagery? Multispectral imagery means the satellite images which are in different bands. Okay, different bands like band 1, band 2, band 3. We call it as red band, blue band, green band. Okay, or IR band. So usually we get these images in list 1, list 2, list 3. So these are all the bands we get the images. That's why we call it as multispectral imaging and with a moderate spatial resolution. So what does it mean? Resolution means we'll be discussing in detail in the coming topics. So resolution is like a scale of the imagery. It's the clarity of the imagery, how far we are able to differentiate the objects in the satellite imagery. So it will give us a moderate resolution. So it can be, we can use it for the land use, land cover mapping or any developmental activities. So it is clear enough to do these all kind of activities. So it will give us the resolution in a moderate way. Now IRS P3. Next we have a series of IRS P3 launched in 1996. So this satellite had sensors of oceanography and atmospheric studies along with the land observation. So this satellite has a sensors of oceanography. It tells about the ocean monitoring system. It will tell you about the atmospheric studies and along land observation system. Next series when you see is Resourcesat 1, Resourcesat 2, Resourcesat 2A. These satellites carry advanced multispectral and multispectral sensors with improved spatial resolutions, launched in 2003, 2011 and 2016 respectively. So these are all series of satellites we see in our IRS, Indian Remote Sensing Satellite System. Now we have Cartosat 1 and Cartosat 2, Cartosat 2A, Cartosat 2B. These are also a series of satellite images, and Cartosat, even Cartosat 2D. So these are the high resolution satellite primarily used for cartographic applications, urban planning, and infrastructure development. So these Cartosat images we get in panchromatic band. We generally don't get these images in the multispectral band. So these images comes in black and white, and but the clarity of the image will be having more. It has a very high resolution images, satellite images, and primarily it has a cartographic applications, and it can be used for the urban plannings and even infrastructure development. So only the problem here is we don't find these images in a color multispectral images, but we find these images in a black and white with a very clear picture, with a very clarity images. Next, we have Reset and Reset 2. So it is radar imaging satellite series. Satellites provide all-weather day and night imaging capabilities using synthetic aperture radar technology. So it will give the information about day-to-day information, all the weather conditions, and it will provide all weather condition capability it is having, and using the SAR, synthetic aperture radar technology. So they are particularly useful for agricultural monitoring, disaster management, defense applications, and various fields. It is very much applicable. Then EOS 1, launched in 2020. So EOS 1 is formally known as a Reset 2B or R2, and is a radar imaging system satellite designed for the applications such as agriculture, forestry, and disaster management. These are few the series of Indian remote sensing satellites. Now these satellites capture imagery of various parts of India and other regions of interest, and the data is utilized by government agencies, research organizations, commercial entities for diverse purposes. So access to these satellite images and data is often provided by ISRO. So ISRO is the organization from where this access of the satellite data is provided, and through National Remote Sensing Center or through authorized distributors, the satellite images are obtained for the further developmental activities. Now we have a table here. So let us discuss the table here, and this is about the major specifications of present IRS series of satellites. So just before slide we have seen there are different series of satellites of IRS 1A, IRS 1B, IRS 1C, IRS 1D, IRS P6, P3. So these are all the series of satellites. So what are their specifications? Just will know in this table. So just we'll see about this IRS 1A and 1B, and it was launched in the year 1988 and 1991, and it has a sensor of LIS1. It has a sensor called as LIS1, and the spectral bands of these sensors is it comes in blue, green, red, near infrared. Okay, so here we can see it comes in list 1 and list 2. So as well as list 1, whatever the list 1 bands are having, same it is having for the list 2 also. So here band range is 0.45 to 0.52 is the blue, 0.52 to 0.59 is green, 0.62 to 0.68 is red, 0.77 to 0.86 is in near infrared. So these are the different spectral bands. So what does it mean? What are the spectral bands? So I hope you remember about the electromagnetic spectrum we have studied in the previous lecture. So in the electromagnetic spectrum, it shows about the bands from shorter wavelength to the longer wavelength, and it starts from the visible region to the long wavelength region. So there we will see the starting range of spectral bands will be from 0.4 to radio wavelength region. So like that, in that we have regions called as blue region that ranges from 0.45 to 0.52, that is blue. And here we have 0.52 to 0.59, we have green, 0.62 to 0.68, that is red, and 0.7 to 0.86 is near infrared. So these are all different kinds of bands we have here. And why it is shown in this band? Because this is the region where passive remote sensing is possible. Okay, remote sensing is possible. So passive remote sensing is done in the visible region itself. So that's why these regions are given here. So this IRS 1A or 1B, it is having a sensor of list 1 and list 2, and it is having a band of 4 combinations. We have a blue, green, red, and near infrared band, and it has a spatial resolution of 72.5 meters. 72.5 meters into 72.5 meters. That means the features which are on the Earth's surface which are of 72.5 meters, that will be visible in the image. So that is the spatial resolution of the IRS 1A and 1B. Now we have a SWAT. Yes, resolutions we'll talk in the coming lectures, so you'll understand more better. Now SWAT, I think we have discussed in the previous lecture. What is a SWAT? SWAT means when a satellite is in the orbit, while rotation it is having a path. Okay, so this path where the satellite will view, where it will see, and it will start from here to here, that is called as SWAT. So SWAT's band will be 148 kilometers. The SWAT band will be 148 kilometers, and it is having a radiometric resolution of 7 bits. Okay, and repeat cycle of 22 days. Repeat cycle means in how many days the satellite completes the entire orbit and comes back to the same position is called as repeat cycle. So it is having a repeat cycle of 22 days. So in 22 days, when the satellite starts from this position, it will rotate and it will come back to the same position in 22 days. Okay, so this is about the IRS 1A and 1B. When you talk about IRS P2, it is having a sensor of list 2, sensor of list 2, and the spectral band as same as list 3. So spectral band same as list 3 means it is having a band of blue, green, red, and near infrared, and the range will be 0.45 to 0.52, 0.52 to 0.59, 0.62 to 0.68, and 0.77 to 0.68. This range will be for the IRS P2. And the resolution of IRS P2 we have here is 36.25 meters. Now here if you see for this IRS 1A and 1B, the resolution here is 36.25, same as list 1. Now if the SWAT, we will see SWAT is 74 kilometers. 74 kilometers means this much area. The SWAT will be 74 kilometers is viewed by the sensor, and it has a radiometric resolution of 7 bits and repeat cycle of 22 days. This has a repeat cycle of 22 days. So that means in 22 days it comes to the its original path for just capturing the information. Like this, we have IRS 1C, 1D, and this was launched in 1995 and 1997, and it is having a sensor of list 3 with a spectral band of 0.5 to 0.59, and it has a band of green, red, near infrared, and SWIR. Okay, and it has a resolution of spatial resolution of 23.5 meters. So this resolution is more better than, this is the high resolution compared to this two, right? So it is having 23.5 meters means the objects on the ground which are of 23.5 meters will be visible in the image. Okay, with a swath of 141 kilometers. Now we have WIFs here. WIFs is a we have WIFs of IRS 1C and 1D. WIFs is wide field sensor, and it has a spectral bands of 0.62 to 0.68, 0.77 to 0.86 near infrared, and it has a spatial resolution of 70.5, and a swath of uh, 810 kilometers, and the radiometric resolution is 7, and the repeat cycle is 24 days, okay, or 5 days. Like that, we have a pan IRS 1C 1D. Pan means panchromatic. Pan here is panchromatic. Panchromatic means black and white image. Black and white image. Okay, black and white image we have, right? Now we have IRSP, and this pan is having the resolution of 5.8 meters. 5.8 meters is a very high resolution compared to this all. We have a resolution of 5.8 meters, but only drawback here is it is in a pan sensor. So pan sensor gives the information in black and white color, and it is not in the multispectral, and it is having a swath of 70 meters, 70 kilometers, and it is having a radiometric resolution of 6 bits, and it is having a repeat cycle of 24 days. Now, like this, we have IRS-P3 1996 with a sensor of MOS-A, MOS-B, MOS-C, and WIPS, and with the bands of 0.755 to 0.68, 0.408 to 1.010 13 bands, and 1.6 to 1 band, and 0.6 to 0.68 red band, 0.77 to 0.86 near infrared band, 1.55 to 1.70 SWIR. So here we have a spatial resolution 1570 into 1400, 520 into 520, 520 into 640, and 180. And the swath will be 195, 200, 192, and 810. So like this, we have a different radiometric resolutions here again. For MOS, we have 16 bits. For MOSB, we have again 16 bits. For MOSC, we have 16 bits again. And for WIPS, we have 7. So, and repeat cycle of these IRSP3 is 24 days, 24 days, 24 days, and 5 days. Okay. Next, in this table, again, we have few more series like IRSP4. So, the sensor will be OCM, MSNR, and like this, we have a bands here, the resolution, and with a repeat cycle of 2 days. So, 2 days means it completes the entire orbit in 2 days. Like this IRS P6, we have list 4, list 3, and AWIPS. So IRS P6 list 4 MX, it is having a very good resolution with a multispectral. So in Cartosat, we have seen that it has a resolution of 5.8. Now here in list 4 only, we have a resolution of 5.8 meters with multispectral. Multispectral means color image. So it will give you a color image with a high resolution, and with a 70 kilometer swath, and then as a radiometric bits, and we have a 24 days of repeat cycle here. Now like this, for AWIPS also we have 56 meters, 737 swath, and 10 is the radiometric, 24 days is the now IRS P5 Cartosat 1, Cartosat 2 we have pan here, and we have 2.5 meter resolution, very good resolution compared to this. So 2.5 meters resolution we have, but only the problem here is we have a panchromatic again. Panchromatic is black and white. Black and white. So we have to take these images for the infrastructure development with a resolution of 2.5 meters, and with a swath of 30 kilometers, and with a radiometric band of 10 bits, and with a repeat cycle of 5. So this is about the Indian remote sensing satellites, their specifications. Now we have different trends in the remote sensing satellites. Different trends means nowadays we have a recent satellites are very with having a very good resolutions, which helps us in the infrastructure development. So since launching of high resolution Iconos satellite series, number of high resolution satellites have been launched. So the important among them are QuickBird, Cartosat 1, Resourcesat 1, and Iconos. So what is a QuickBird image? QuickBird image was launched on 18 October 2001. And this is currently the highest resolution commercial satellite data available So highest resolution data available means Fitbird acquires 61 centimeters, that means almost 2 foot resolution, panchromatic black and white, and 2.4 2.44 meters, 8 foot multispectral images. That means in panchromatic, we say 2 foot means 61 centimeters on ground. On ground is visible in the image. Visible in the image. But the thing is, here it is black and white. Black and white. Now, if you want color image, so 2.44 meters multispectral, multispectral 2.44 meters multispectral on ground. So whatever image, whatever object which is of 2.44 meters, around 8 foot, will be visible in the image. So at 61 centimeter resolution, buildings, roads, bridges, and other detailed infrastructure became very much visible. Okay. So Pigmart was a high resolution commercial Earth observation satellite launched in 2001. It is launched by Russia, and it was developed and operated by Digital Globe. Pigment provided very high resolution imagery with a spatial resolution of 0.6 meters, about 2 feet. And this level of detail made is valuable for various applications, including urban planning, agriculture, environmental monitoring, and defense intelligence. So this image, as it is very much clear, it is image where we can see the buildings and all the infrastructure will be visible very clearly. So it is helpful for the urban planning activities. It is helpful for the agriculture. It is helpful for the environmental monitoring and defense intelligence. However, it was eventually replaced by newer satellites with even higher resolution and improved capabilities. Now, this is one of the QuickBird image. You can see how clear it is. Where Google Earth, we see very clearly. Same like this image is very clear image. When you zoom to the maximum level, the clarity remains the same. So the objects which are of 61 centimeters on the ground will be visible on the image. So very clearly we can see these are all fields here, and that too harvested. Okay, these are all fields harvested. These are all forest, and you can see the road here clearly, and you can see the building here. Okay, very clearly buildings here and roads here. So the image clarity is so good, so that it is very clearly we can use it for the land use land cover mapping. You can see a canal here going like this, water body, right, which is flowing through it. So very clearly it is visible where you can identify the features for the infrastructure development. You can just go with the land use land cover mapping, and we can just go for the other infrastructure activities. Now there is one more imagery here. So the clarity of the image, you can see these are all pyramids. So clearly it is visible here. You can see, okay, small pyramids, big pyramids, and it is a total desert area. Now here also you can see this area is like roads. We can see buildings. We can see water body. We can see, okay. So small information like settlements, residential areas. We can see these are all images. So the bird is having of 61 centimeters. Whatever objects of 61 centimeters on the ground will be visible in the image. The satellite was equipped with advanced imaging sensors, including panchromatic and multispectral cameras. So it has two types of cameras or sensors, we can say. One is panchromatic as well as multispectral. So we have seen that panchromatic means it is having a resolution of 61 centimeters. Multispectral cameras means it is having a resolution of 2.44 meters. So which captures the images across the various bands. These images are widely used for the urban planning, environmental monitoring, agriculture, defense, and other applications required detailed geographic information. QuickBird played a significant role in advancing our understanding of Earth and change over time. We can see one more image here. This is a very clear picture of QuickBird image. QuickBird imagery of Hyderabad airport. Okay, very clearly the aeroplanes are visible here, and the airport is visible here. You can see the buildings over here, roads over here. So whatever changes in the land use pattern, you can just see over here. So this is the airport here. So this is the runway here. So you can just see very clear picture of this um, land use patterns. Now coming to the Cartosat. So Cartosat was successfully launched by ninth flight of ISRO Polar Launch Vehicle. Now Cartosat is an Indian satellite, so it was launched by India ISRO, and the Cartosat carries two panchromatic cameras take black and white stereoscopic pictures in the visible region of the electromagnetic spectrum. So, what is stereoscopic pictures? So, I hope you remember when we have studied about photogrammetry. Stereoscopic pictures means the photos which are having one pair of photo with the overlapping area. Okay, overlapping area. This is photo 1, this is photo 2. So it has an overlapping area over here. So this two overlapping photos are required for the 3D vision later. So that's what it is called as stereoscopic pictures, and it will just capture the information in the visible region of the electromagnetic spectrum. So visible region is 0.4 to 0.7 nanometer. In this region only these pictures are taken by this Cartosat. So the imageries have spatial resolution of 2.5 meters and cover a swath of 30 kilometers. So what is swath? Swath means this is the path which is covered by the satellite. Okay, this is called as swath. The Cartosat series of satellite are Earth observation satellite operated by Indian Space Organization ISRO. So these satellites are primarily used for cartographic applications, urban and rural planning, infrastructure development, and various other geographic information system and GIS applications. The Cartosat series has seen several iterations, each with the advancement in imaging technology and capabilities. They typically carry high resolution panchromatic and multispectral cameras to capture detailed imagery of the Earth's surface. So these satellites play a crucial role in various sectors such as agriculture, forestry, urban planning, disaster management, environmental monitoring. And one notable feature of Cartosat satellite is their ability to provide the stereo imaging. They provide a stereo imaging which enables the creation of 3D. So the main advantage of Cartosat satellites is it has the ability to provide a stereo image, or we can just say it provide us stereo images like stereoscopic pictures for seeing the three-dimensional terrain. So, what is stereoscopic pictures? Just now I told you there are two photos with overlapping area. Okay, two photos with overlapping area. So, when you keep photo 1 and photo 2, or satellite 1 and satellite 2, we are able to see the 3D vision of these overlapping areas. So, it has this capability. So this capability is particularly useful in the applications of such as urban planning, natural resource management, disaster response. So overall, the Cartosat series contributes significantly to India's space program and it efforts at utilizing the space technology for society benefits and national developments. So this is one of the Cartosat 1 satellite imagery. So see the clarity of this imagery as it is a black and white image. It is having the resolution of 2.5 meters. Okay, so this is, you can just see this roads here, buildings. Okay, it's like a stadium somewhat here. Here also you can see like a stadium. Okay, these are all small buildings which are visible. So because it is a black and white image, the identification of the features will be somewhat difficult. So when we merge this Cartosat image with this color image, then we'll be having a clarity image as well as with a color image also. Then we can just identify the feature. Now Cartosat 2 is one of the satellites in the Cartosat series operated by Indian space research organizations. It is specifically designed for high resolution and Earth observation missions. Cartosat 2 satellites are equipped with advanced remote sensing instruments capable of capturing high resolution imagery. So Cartosat 2 satellite images they are very much well equipped with the advanced remote sensing instruments, and they can capture high resolution imagery of the Earth's surface. and it has a high resolution imaging like Cartosat 2 satellites are equipped with high resolution panchromatic and multispectral. Everywhere we are just coming across with these words panchromatic and multispectral. That means it has a high resolution with black and white as well as it has a color. Both images it has, and it will provide a clear picture with a high resolution too. So energy surface. These cameras can provide imagery with spatial resolution ranging from sub meters to few meters. Okay, ranging from sub meters to few meters. That means very high resolution. Sub meters means below 1 meter to 1 to 2 meters resolution. It will be visible in the image. Next, stereo imaging, and it is having a capability. Cartosat 2 is having the capability for stereo imaging. What is stereo imaging again? Stereo imaging again, I will say it will give a overlapping images to see the three-dimensional 3D of the that particular land part, and here capture stereo images which enables the generation of three-dimensional terrain models. This feature is valuable for various applications including urban planning, terrain mapping and disaster management. Okay, and it has a multiple applications too. The high resolution imagery captured by Cartosat 2 satellite finds an application in a wide range of sectors including cartography, urban planning, agriculture, forestry, infrastructure development, disaster management, and environmental monitoring. So it has a multiple applications where it can be used for. It is widely used also, and basically it is generally used for the urban planning because it has a very clear picture. So planning will be more easier with this satellite images. Next, we have operational flexibility. Like Cartosat 2 satellites are designed to be highly agile, so allowing them to be maneuvered to capture imagery of specific areas interest with a precision. This operational flexibility enhances their effectiveness in the various Earth observation missions, and Cartosat 2 satellites play a very crucial role in the Indian space program. It contributes significantly to the country efforts and utilizing the space technology, social benefits, national development, and strategic applications. Now coming to the ResourceSat 1. So ResourceSat 1 is the satellite which provides us the resource data, the land information. It's an Indian satellite and it is having a series of IRS P6 ResourceSat 1, and it conceptualized and designed to provide continuity in the operational remote sensing with its superior capabilities. So its objectives is to provide continued remote sensing data for integrated land, water management and agricultural and its related applications. So ResourceSat 1 is an Indian remote sensing satellite launched by Indian Space Organization ISRO on 17th of October 2003. It was the first satellite in the ResourceSat series aimed at providing high-resolution imagery for resource management and monitoring purposes, and the satellite carries three payloads. And LIS-3 Linear Imaging Self-Scanning Sensor 3. This payload provides high resolution of 24 meters. So it carries the LIS-3 is linear imaging self-scanning, and it is having with the resolution of 24 meters means the 24 meters on the ground, the objects which are of 24 meters on the ground which will be visible in the image, and that too it has a multispectral or spectral, four spectral bands. Then we have LIS-4 provides the information in LIS-4. So linear imaging self-scanning sensor 4. So LIS-4 provides medium resolution of 5.8 meters multiple spectral imagery in the three bands. Now we have AWIPS. AWIPS is Advanced Wide Field Sensor. So AWIPS Advanced Wide Field Sensor captures the wide swath imagery with high spatial resolution of 56 meters in four spectral bands. Now, ResourceSat 1 was designed to provide data continuity with its predecessors and the IRS series of satellites while also improving upon their capabilities. It has been used for various applications like agriculture, forestry, land use mapping, urban planning, disaster management. So everywhere we are seeing these all are resource-based satellites which provides the land information. So this will be very much helpful in the land use planning as well as our urban planning and as well as disaster management too. So the data acquired by resource set has widely used by the government agencies, research institutes, commercial entities, monitoring and managing natural resources and the environment. It has contributed significantly to India's remote sensing capabilities and its utilization for socio-economic development and environmental sustainability. Now, you can just see over this images. We have two images here, A and B. So what does the A says? So these are the list IRS list 4, P6 list 4 image, FCC image, that is false color composite image, that too it is in color image. Now if you see in this pre-event is, here is the area which is having a landslide zone, and this is the area affected by the landslide. So this is the lake which is affected. So this is before pre-event, showing the location of the landslide area induction due to the lake formation, and second one you can see post event. So after the landslide, how was the land, FCC imaging showing the landslide damage the lake. So this portion is damaged by its landslide here. The land has slided down. So it will be helpful in the planning of the landslide disaster management. This is landslide means disaster management. It is very much helpful. You can just take these images and we can just go for the planning of the disaster management. Now we have one more image here, IRS-P6 list 4 MX image. The image is produced for the land use land cover mapping. Like we have a road here, all the settlements here we can see, the water body we can see. Okay, this is a river we can see here, right? All the vegetation here we can see. Next we have ICNOS. ICNOS is a commercial Earth observation satellite system, and it was launched by the Space Imaging in September 1999, becoming the first high-resolution commercial satellite collect data at less than 1 meter resolution. Panchromatic 0.82 will be available in 0.82 to 1 meter and 32 to 39 inches, whereas multispectral it is available in 3.28 to 4 meters, that is 129 to 157 inches. So the ICNOS satellite was launched from Vandenberg Air Force Base, California. This is a California United States satellites, and it has both cameras. It has a panchromatic as well as multispectral. So panchromatic camera or sensor, we can say it will give the information about with a resolution of 0.82 to 1 meter. That means the features which are of 0.82 meters or 1 meter on the ground, it will be visible in the image. That too, it is a panchromatic, whereas multispectral, when you talk about it, it gives a resolution of 3.28 to 4 meters, and it you can see 129 to 157 inches. So the ICNOS satellite was launched by the California, and the ICNOS satellite was capable of capturing detailed images of the Earth's surface for various applications, including urban planning, agriculture, forestry, environmental monitoring, and defense. This is one of the ICNOS satellite image of Vatican City. See how clearly we can see this roads and all the buildings here, right? This is the plan of the city we can see. Here is the road, buildings, vegetation. Okay, so this is ICNOS satellite image. Though, so it has a very clear picture, and that too it is a multispectral which will give the information in with a 3.28 to 4 meters of resolution. So that means 3.28 to 4 meter of resolution on the ground will be visible in the satellite image. Right? So these are the references for this topic. Like we can just refer these books, like we can refer MNG Reddy, Remote Sensing in GIS from BS Publications, New Delhi. You can refer this types of satellites, Indian remote sensing satellites, their specifications, series of the satellites. You can just refer in this book, and you can just go with this Fundamentals of Remote Sensing by George Joseph, University Press, Hyderabad. Or else, if you want to just go through more content, you can just go through this NPTEL link is there. where you can just click and just go through the different topics of this subject. Then you have by S. Kumar, you have a basics of remote sensing in GIS by Lakshmi Publications. And later, if you want to go through about the GIS, you can just refer to the Tang Chan and GIS with TMH Publications and Corporation. And next is remote sensing in GIS by B. Bhatia, Oxford University Press, New Delhi. So these are all references you can just go through and find out the more content about it. So that's all for today. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.